All right, well, hi everyone and welcome. Today we are going to look at a few things. In particular, we're going to look at a front-end stack based on the ClojureDart language. In particular, we're going to focus on state management on the front end. We'll be exploring the data loop that Reframe popularized. We will see how we deal with derived data and how we can create materialized views from our state. And we'll explore whether we can use or which state stores we can use to actually store our state, like databases, etc. This talk will focus on ClojureDart, and it would be beneficial if participants are aware of ClojureDart, or at least have seen some previous material around it. And also with Reframe, it's not the end of the world if you haven't, but it would be good. All right, so the front end stack. At the company, we were looking for something that were truly cross-platform in the sense that we have a single code base that we can develop our application in, that can compile and run on each device, mobile, web, desktop, and purely a single code base that we do not have to adapt per platform that we're targeting. We looked at a few and eventually landed on Flutter, which is the SDK developed by Google, or the UI toolkit developed by Google. It provides rich UI widgets that you assemble together, and you can create like full-featured, beautiful applications once, and it runs on all of our lovely devices. To develop a Flutter application, we develop in a language called Dart, also developed by Google. Dart has the tendency to be a bit verbose, and there's quite a bit of boilerplate involved to develop your application. And as Clojurists, we shy away from large code bases, so we try to be as concise as possible. So as we looked at these options, we were very happy to discover ClojureDart. And ClojureDart really takes our favorite language, Clojure. It compiles it to Dart, which in turn gets compiled to the Flutter runtime. So this allows us Clojurists to use our favorite language and develop cross-platform, truly cross-platform applications. If you're not familiar with ClojureDart yet, I would encourage you to check out this London Clojurians talk from the creators of ClojureDart, Joyful Mobile Development. It's well worth a watch, and it dives into exactly what ClojureDart is and how you can build an application with it. So before we look at global state, it is worth looking first at what local state is. So what we have here is a small application on the left-hand side. It is a simple counter application. Click the button and the counter increments. And on the right-hand side is the typical layout of a ClojureDart application. In this case, we have a main namespace, and we require the Flutter package, as well as cljd.flutter. And cljd.flutter is provided by ClojureDart, and it is a library that allows us to get rid of a lot of the boilerplate inherent in a Dart or Flutter application. So we will typically have a main function in which we start bootstrapping our application. So we define material app, we define a scaffold, we can add some drawers to it if we want, and then we start building our widget tree from center, and F widget downwards. So here, F widget is a macro coming from CLJD.flutter. And really, this is a very powerful macro. I think the ClojureDart devs call it the macro of all macros. And it builds a stateful widget in the Flutter ecosystem, but you provide it with a few directives. So there's a whole list of directives. This is a watch directive that we're looking at. But if you look at the Clojurians talk I linked earlier, you'll see there's a whole host more that is possible. What we're interested at the moment is how we can use it to enable local state in our application. So here we have a watch on an atom. This is a local atom that we've defined on the widget itself. It's a simple integer wrapped atom. We bound it as the state variable. And what this watch will do is it will dereference the current value of the atom into the current count variable. And this current count variable, as soon as it gets updated with a new value, in other words, as soon as the atom changes, the rest of our widget tree below will update and re-render with the new value of current count. In this case, we set the current count value as the text label that we see on the left-hand side. Also, to update the atom, when we click the button, we swap the state and increment the counter. So what we have here is an example of a full application with no need for global state, because everything can remain local to the widget. And this is perfectly fine. Inevitably, our application might grow, and we might run into a scenario where we would like to share this atom containing our state to other parts of our application, other views in other namespaces, or other namespaces not tied to views, or whatever the case may be. And this is where a state manager can become useful. So let's look at state management options. If we look at the Flutter and Dart ecosystem directly, so without any ClojureDart involved, there's a myriad of options to choose from for state management. Some of these may ring familiar to us, like Redux was borrowed from the JavaScript world, etc. So there's quite a few. And the interop between ClojureDart and the Dart host is very good. So I'm sure that some, if not all of these, will be very usable from a ClojureDart application by means of using interop between ClojureDart and Dart. I haven't tried it myself. I am biased towards a specific state management solution called Reframe, which is what we will focus on in the next bit. So the thinking was, wouldn't it be nice to have ClojureDart specific options available for state management and try and grow our own cloud like we see in this Flutter ecosystem for ClojureDart. So let's change gears towards ClojureDart state management. By default, as I've mentioned earlier, we get provided with cljD.flutter. And I call it bring your own atom. So what this means is for global state, we define our own global atom somewhere in our namespace. And we then pass it into our widgets that need it. To be able to share this atom between widgets or between views of our application or alongside our widget tree, the fwidget macro provide directives like bind and get to be able to share this atom to other parts of our application. And also in cljd.flutter, this is not a fully encompassing list. Obviously, there's a lot more in cljd.flutter, but for this talk is reactivity that is achieved by means of cells, which is a data type in ClojureDart that we'll have a look at in a bit. And really, you can build full-fledged applications using this approach. A secondary state manager is not necessarily necessary. Out of the box, you get features to use your atom. One thing to bear in mind with this approach is that you, like I said, you define your own atom and you are responsible for updating it and passing it along. It is not done for you. Secondly, we have Flutter MX. Flutter MX is a Flutter wrapper in the sense that the current widgets Flutter provides is wrapped, like your text field, etc. It uses the matrix state management library inside. And the idea is that state is managed in place or property to property. So per wrapped Flutter widget, we store the state relevant for that widget. But to get more information around Flutter or Flutter MX, have a look at the Clojurians talk that Kenny gave that discusses this in a lot more detail. Thirdly, in our ecosystem, we have Redash, and this is what we're going to look at today. Redash is reframe inspired. So for anyone coming from the ClojureScript world, you might be familiar with reframe. It is a separate secondary store of state. And by that, we mean that our state is decoupled from our views so that it can be reasoned about separately. The state is still represented as an atom, a global atom. The difference is this atom is fully managed by us for Redash, so we don't have to create it and pass it along. The way that we interact with this atom is by means of events that update the atom and subscriptions that read from the atom. And there's a few extra features that Reframe provided that subsequently is built into Redash, like the ability to handle side effects at the edge. Again, what does that mean? It means we do not have to directly access side affecting things from our views itself. If we want to follow the philosophy of Reframe, it is keep your views pure and indirectly access things like global state and anything that can create a side effect like a server request or writing something to a file, etc. So Redash provides you for facilities to handle that. Lastly, derived state. So having a full-fledged state manager with state as a separate thing, it allows us to build some rules over that global state that allows us to derive values from other values in our state. And we'll have a look at that as well in a bit. So if we focus on Redash state, what do I mean by it? It is basically a map in its simplest form. What is contained in this map? Well, anything we want. We can store our current count variable from our counter application in there. We can segment our map however we wish. For example, we might store user data under a special key and anything related to UI state under a separate key. But really, we are the map is open and we're allowed to store whatever we want in there, in whatever format makes sense to our use case. So how does this state get transferred through our application? Reframe came up with this idea called the data loop. And the data loop really is a unidirectional flow of state through our application. And Reframe and as such Redash can be considered as this perpetual loop on which we can hang off certain functions in certain places to deal with things like events or side effecting things. So reframe uses the analogy of dominoes. So they've got 6 dominoes, and we'll get to why there's only 5 on the screen at the moment, but 6 dominoes, meaning one domino falls and kicks over the next domino and the next and the next and so on until the process repeats. So firstly, we'll have an event dispatch domino, and this is where the user clicks a button, for example. This event gets put asynchronously in a queue, an events queue. And in terms of Redash and Dart, we use the queue Dart type in Dart to handle this queue for us. So the event gets put in the queue, and then the second domino is handling this event. So these events get handled in order that they are dispatched. And the event handling step really declares a set or a collection of side effects that we want to have happen. It does not actually do the side effecting thing. It purely declares what needs to be side effected. Either update the app state or send an email or do some server request. Third domino is our effect handling, where we actually do the work of mutating the app state atom or sending that email. Then the fourth bit is where we define or we give the ability for the UI to query our state. And this is done by means of subscriptions that we'll have a look at in a bit. But really the subscription responsibility is to extract the information from the map based on some path query that it's been given. The subscription also needs to deduplicate the results such that it can only result in a view that reacts to changes and not when the value that being queried has not actually changed. And thirdly, our query step part of the subscription would be the ability to compute a materialized view from the inputs in our state. So then we get to the fifth domino, which is our view actually subscribing to this subscriptions that we've defined in step 4, and reactively delivers the result of the subscription to our widgets so that they can update with the new information. The sixth domino is more platform related. It relates to the runtime itself, drawing the pixels on the screen, or in Reframe's case, it would be the browser updating the DOM. And this is the data loop, and the process starts again from 1. So if we start looking at these in detail, the first one, event dispatch. This is typically an example. If we, this relates to our local state example we saw earlier. It's the same kind of widget tree. You'll notice that the application is split here into a view namespace. So the way we structure our applications can be however we want. I find it useful to have a view namespace to define the widget tree for a specific view I'm building, and a model namespace containing all the events and subscriptions, etc., that we'll look at in a bit. So the first thing we'll need is a require for Redash. And the way that we dispatch this event would be to call the dispatch function in Redash, and we pass it a identifier of the actual event that we are dispatching. In this case, it is the event with the name count in our model namespace. So you'll notice here that we do not swap out an atom directly anymore. We indirectly update state by dispatching an event. So the next step will be to see how this event actually looks. So this is our event handling domino, step 2. You'll notice that we have a model namespace in which we can register all our handler functions. And this is done inside a register function. Any users of reframe will immediately recognize this as a place where redash deviates from reframe. So in reframe, you typically register your events using regEventFX in the top level namespace. In other words, not inside another function called register. And the reason we have to do it like this in redash is if we were to register our events in the top level namespace, there would be no direct statically analyzable route to our code, because the Dart compiler, when it compiles our code, will do what is called tree shaking, which is to get rid of any unused code, and all our events will just get lost. So what we do here is we wrap all our events that we register and subscriptions, etc., inside a register function. And this register function is something that we call from our main namespace. So I'm just switching to my application code. We'll have a main namespace in which we just call our register function. And by this way, we ensure that the Dart compiler sees there's a reference to our registrations and it won't tree shake it out. So what we do here with registering events is we call regEventFX. We give it a name here with count, and we implement a handler function. This handler function gets given two arguments. The first argument is a map, and it is known as a co-effects map. Co-effects in the sense that redash will provide the current state of the world to this handler function as co-effects. And one of these co-effects is the DB, which is the dereferenced value of our current global state atom. And we'll see later we can register other co-effects that can be given to our handler function, such that our handler function can have everything that is needed to do what it needs to do. The second argument here you'll see is not used, but this would be any arguments that is passed in our dispatch step will be accessible here. So we'll notice here that what gets returned is a map of side effects or a map of effects. So in this case, the map contains one key called DB, and DB is a pre-registered effect. So in other words, we as developers don't have to register the effect ourselves. It is given to us by redash. And this defines the new state of our app DB that we want to take effect. So in this case, we update the DB and increment the current count. So what we end up with here is a pure function, pure in the sense that there's no side effects actually taking place. We just return what we want to have happen. And also the handler function gets fed everything it needs to do its work so that we can easily test this function and we can be sure that the same inputs will result in the same output. There is as with reframe, redash supports the second variant of registering an event called regEventDB, which is a little bit simpler in that it will be given the DB itself as an argument, not a map of co-effects. And in the same way, we then return the DB as is. We don't have to return a map of side effects. That's just for anyone familiar with reframe. So this is a simple case where we return one effect, purely updating our application state. This can be extended to return more effects. In this case, we return a second effect called log count. And in this case, it is an effect that we have registered ourselves. And we'll see now how that is done. And we pass the argument of new count to this effect. And the purpose of this effect is purely to write something to a file, just to demonstrate what side effects is. But this means we can return any kind of effect that we want to have happen. And as with reframe, we support things like the fx key that you're able to pass in a vector of effects and all of the goodies that come with that. So if we look at the third domino, which is our effect handling, here we still have our same event above, but now we've registered an effect as well using the regfx function in Redash, and we've called it log count, like we've seen in the previous slide. This handler function gets provided the new count argument from our event handler, and we can do whatever side effect is necessary, in this case, just printing it out. Fourth domino is our query. So in this case, we register subscriptions, and subscriptions is registered using the reg sub function of Redash. Again, we give it an ID called getCount, for example. And our handler function in this case, again, gets passed the DB, which is the dereferenced value of our current database. And we are able to extract out of this DB whatever we need to provide in the subscription. So this is what is known as an extractor function or an extractor variant of a subscription, where purely the intent is to extract a value from our state. And under the hood, this is where it gets interesting with Redash, how this is able to reactively deliver results to our view. I've mentioned previously that CLJ Flutter provides us the cells data type, and cells is very, very useful. It basically acts the same as a spreadsheet cell in that the value only updates whenever each of its dependencies update. And you can subscribe or you can watch a cell for a changed value, and cells can be wrapped around cells, etc. And that kind of mechanism is used in Redash to enable reactivity using subscriptions. But all of that is hidden from the Redash user. So this is our first extractor variant of a subscription. Also, yeah, you would have noticed the second argument in the previous slide we didn't use, but we can use it, and it's basically a query vector. So it would be given by the view that needs to subscribe to a specific path or a value at a specific path in our map. So in this case, the query vector can be used directly with Clojure's getIn function to be able to get a deeply nested value inside our map. And this is very powerful because our map can be a very deeply nested map. It doesn't have to be a flat map. We can get to whatever we need to by using Clojure's functions like getIn. Then subscriptions has implemented what is called, or what Reframe has called, the signal graph. And this allows us to subscribe to other subscriptions. And in this example, you'll recognize our getCount subscription above, which is our normal extractor variant of subscription. But at the bottom, we have a second subscription, count multiplied. And this variant of reg sub defines two handler functions, or we implement two handler functions. The first is a signals function where we subscribe to other subscriptions. And the value of these subscriptions, when they change, get passed to our computation function as arguments. And in our computation function, we can then in turn do any performance or like performance intensive calculation or not. But the point is that the problem the signal graph tries to solve is that our computation function only executes when its input signals actually has changed. So in this case, our computation function only gets run when the value derived from our get count subscription actually changes. So this is one way we get derived data. So derived data meaning we derive some value from our computation function based on input values existing in our database. We can subscribe to, or we can provide multiple signals to our computation function. And in this case, we provide a vector of subscriptions, get count 1, 2, and 3. The third one is a typo. And then the results of these 3 subscriptions will be given again as a vector to our computation function. And we can be sure that our computation function will only execute if at least one of these input signals has a changed value. Otherwise, our computation function won't execute. So it's a performance optimization thing, borrowed from reframe. So this brings us to our 5th domino, which is, if we remember how our view looked before, we can now, instead of watching the local atom, we can instead watch a subscription by means of the subscribe function in Redash. And again, our subscribe function takes the ID of the subscription, in this case, get count, that we've defined in our model on the right-hand side. So here we end up with a view that is completely disconnected from having direct access to state or side effects. We completely indirect the usage of state and side effects. So for the purists among us, this can be seen as a pure view, which is what reframe strives for. Right, so we have looked at derived data by means of using subscriptions. And in the last few months or so, the reframe developers have looked at this problem of derived data, and they've come up with a few shortcomings of subscriptions. And even though we have the ability to have a signal graph which is the performance optimization such that our computation functions doesn't unnecessarily execute. It only executes when the inputs actually change. The problem is that subscriptions are tied to the view's reactive context. So we can't really use or as easily use the logic behind our computation function in other parts of our application, because it only ever really executes when it gets dereferenced from the view, or when our view gets rebuilt and the subscription gets queried, then only does our computation functions execute our logic. And the second problem was that we can reason about the result of our computation function as being state, but it is state not stored in AppDB. So in the philosophy of reframe, the idea is that state and any state should ideally be kept centrally in one place inside AppDB, and subscriptions does not really do that. So what they've come up with in the last few months was the concept of flows. And flows is a brand new concept that is still in alpha in the reframe world, and we have implemented it in Redash as well. It is also under alpha at the moment. But what a flow is, essentially, it allows us to use derived data and the calculation that gives us the derived data in event handlers, not only in subscriptions. The results of our computation function is stored in appdb, which means it is automatically cached just by being in the appdb. Other subscriptions can query this result stored in appdb directly without having to recalculate our computation function again. And Flows Flows implements its own life cycle so that we are in full control as to when the computation function of the flow executes and when not. So what is a flow? A flow can be defined as a map. In this case, we gave it an ID and we define some inputs. And this inputs can be compared with the like the query path we've seen in subscriptions. It defines a path in our appdb. So in this case, under the garage width path in our appdb. And we define that the result of width and length will be stored in a map under the key W and L in this case. But these inputs really will, when this flow executes, these inputs will be given to our output function as arguments, and our output function will do the computation necessary to come up with a derived value. And the result of this derived value is stored in the appdb under the path we define here. So importantly, a flow is a concept or a thing that gets executed on each event dispatch. So every time any event in the system gets dispatched or handled, in that case, each flow that is registered gets executed. And our output function will only ever execute when the inputs actually have changed values. So if we just click the increment counter button 100 times and nothing changes our width or length in our database, our output function will not run again. But if those do change, we have a value stored under path. How do we register flows? So we have two ways. We can call the regFlow function in Redash. We'll be passing our flow definition defined on the left. This registers the flow at app startup once, and it's globally available, and it will for always listen or run when events actually gets handled. And the second way is using an effect called regFlow. So this is an example of an event, some event that registers a flow, but this can be any event. The user clicked the button or whichever the event is. As one of the side effects, we can return the effect called regFlow. Again, this is an effect that's pre-built and pre-registered by Redash. And it allows us to, at the time that this event gets handled, we can register the flow. And the flow will, in turn, become alive and start executing its output functions when its inputs change. Subsequently, we can deregister a flow using the clear flow effect whenever we need to. So we can handle the life cycle of flows by means of controlling when we register and deregister a flow. Flow's life cycle can be further controlled by means of a liveness check. So in this case, we again define inputs to our live function, which is a path to a value in our app state, and the value of this path to kill switch in our example will be given to a live function that we can define and control to determine whether this flow should be alive or not. If this live function returns false, then obviously this flow will not execute on every event being handled. If live returns true, which is the default, our flow will get executed. In the reframe documentation of flows they use a nice example of a tabbed screen where the user can be either on tab 1 or tab 2. And when the user is on tab 1, the flow is alive, so the output function executes as and when the inputs change. But when the user switches to tab 2, value will be written to the app database, like this kill switch, to say this flow should not be alive anymore, which means while the user is on tab 2, even if the inputs were to change, the flow would not execute. So we have various ways to control the flow's lifecycle. So I think this is pretty neat. We have now 2 ways to handle derived data in Redash. And I think I mentioned earlier, it is also under alpha at the moment in Redash. As soon as it graduates out of alpha in the reframe world, we will subsequently graduate it out of alpha in Redash as well. There's some more features. I touched on co-effects. Co-effects, I don't have an example at the moment with me, but we register co-effects as well in our model using a reg co-effects function. This co-effect is a side effecting function, so it's allowed to go out to the outside world, and it can go do a server request, or it can be as simple as taking the current time from the current system clock and returning that as the value. The whole idea behind it is that this map of co-effects gets passed or gets given to our event handler function, such that our event handler function doesn't have to go and do that work and fetch that information from the outside world, so that the event handler can remain pure. So I think Reframe talks about co-effects as the current state of the world as it exists, and it will be given as a snapshot to the event handler. Interceptors is another feature. So as with Reframe, everything around the data loop processing is implemented using interceptors. So if anyone's familiar with pedestal in Clojure, the interceptor pattern is the same one being used here. An interceptor is purely a thing with an enter function and an exit function, or a before and after. So it gets called at the relevant stages as the state flows through our event processing. An example of an interceptor can be inject co-effects, which is how we actually inject our user-defined co-effects mentioned above into our event handler. And there's a couple more. There's, for example, debug, which is quite useful, and I think it's a good stage to switch to an example. So if we look at our running application, so I'm just going to bring it up on screen. So this is our counter application running, and it's the same thing we've been looking at so far. We have a count event, which will increment the counter, update the appdb. It will log the result using the effect to the console. And the get count subscription is used by the view to actually display it on screen. So we can see that in action by clicking the button. We can see our subscription running and our effect writing to console. So this is very simple, but in terms of more elaborate application, we might want to get some debug information or do some troubleshooting and see what actually happens with our app state before and after our event actually runs. So we do that by using our debug interceptor. And what we'll do here is we pass in a vector of interceptors, in this case, only the debug interceptor. I'll for now just comment out the logging to console so that we don't get too much noise. So if I reload my application, if we click the button, we we see nothing happen because I haven't actually called my debug interceptor. So let's try that again. Right, so now we get some information that's useful for debugging. We can see which event has executed. We can see a diff of the database before and after our event got handled. If we do this again, we can see we had one, we incremented it to 2. And this is very useful for debugging. This debug interceptor itself has got a few options. It's in the Redash documentation. But for example, one can be, let's say we are not interested in seeing the diff because all we want to see is the name of the events that actually gets handled. So in this case, we simply get our event ID that gets handled. And to make this even more useful is we have the ability, as with reframe, we can register global interceptors. And by registering an interceptor as global, we are able to intercept all events, and this debug will highlight exactly which events is handled in which order, and this will give us a very nice indication as to what's happening in our application. Right, let's get rid of these. And of course, we can write our own. Another feature, or more of the features, is things like testing helpers. So due to the asynchronous nature of event handling, it is a bit tricky to test those. But Redash provides some utilities inside the hdi.redash.testing namespace that allows us to test our event handlers and subscriptions. And there's some examples in the Redash documentation or in the Redash testing namespace of how to do this. But we can, for example, call, instead of calling dispatch, which will put the event on a queue, we can call dispatch sync, which will bypass this queue and immediately update the AppDB synchronously so that our subscription can get access to that in our test. Also, with regards to subscriptions in our tests, there is a special subscribe in the testing namespace of Redash that's able to deliver the result of our subscription via an atom as opposed to a cell, because again, a cell is tied to the reactive context of Flutter, whereas an atom is not. But using some of these helpers, we will go a long way to help us to make testing easier. Some general tips that I've picked up along the way is the way that we name our handler functions. So what we've seen thus far is naming our functions using an aliased keyword. And that works fine, and mostly it'll be okay for a smaller application. But inevitably, as your application grows, you break up your application into more and more namespaces, inevitably you will run into circular references just because of the fact that we're using aliased keywords. So a recommendation is, instead of using aliased keywords, use namespaced keywords, global namespaced keywords instead. It can be descriptive, like in this case, and we can use it and pass it along anywhere throughout our application without worrying about circular references. Another recommendation is extract your handler functions. So instead of having an anonymous function inside our reg event fx, for example, extract it to the top level namespace. It just tidies things up a bit. It keeps all the registrations nice and tidy together, and our functions is at the top level, able to be easily unit tested. Further, we can consider normalizing our AppDB structure. So as I mentioned, initially we are free to structure our database however we wish. But in a growing application, this can quickly become unwieldy. So Eric Normand has got a great article in which he describes the indexed entities pattern in how a database structure can be normalized such that we index our entities and reference them by index in other parts of our app.db so that we don't duplicate data, and the lookups can be very quick because it's indexed by the entities as ID. So that is also very useful. Right, I think that covered most of it. Looking towards the future, recently I've been working on the ability to plug in more databases usable as app state in Redash. So what we've done is we've created a database protocol of which the app.db is the default subscriber for implementation of this protocol. And the app.db is our normal map pattern that we've been using so far. But also we've implemented database implementations for Drift and RxDB. Drift is a Flutter wrapper around SQLite 3. And it is nice because it is a reactive database implementation. And where that becomes interesting and powerful is the fact that we can have the power of a complex SQL query that is subscribable, such that Redash subscription can subscribe to a complicated query and deliver the results reactively to our view. That is quite powerful. And with RxDB, which is used in the JavaScript world, the RxDB developers have also subsequently created a Flutter adaptation of it. And this is also added support. I've added support for it in Redash to be able to use RxDB if a NoSQL database is more to your liking. And hopefully one day we can have DataScript available in ClojureDart. It's not at the moment. There's some work needed to port it. But the hope is that this structure built into Redash to be able to register more database implementations will lend itself nicely to a DataScript implementation. And whichever else we want, as long as we implement the database protocol, we can come up with creative ideas to add more state stores in Redash. So I'll quickly switch to the documentation in the Redash repository where this is described. So just for context, this is a new feature. Hopefully it will be merged to main soon, but it is really in a feedback stage where we would like feedback from the community. There's a PR open that describes it, and feedback is welcomed to see whether this is something that can be useful or whether it needs to change a little before we merge it in. So the idea behind it is that we register a database, and we do that with a new function added called regDatabase. regDatabase, we give it some ID, and we instantiate our database protocol implementation, which is provided for by Redash, and an instance of our database, of the Drift database itself. So how this all gets tied together can be seen in the Drift documentation as well. But there is a sample in Redash, the samples folder, that has a fully running application using Drift as app state. Importantly here to note is that we have the ability in Redash to register multiple databases that can work concurrently with each other. So if we decide to register a database here to support some Drift queries, we still have access to our app.db in our subscriptions and effects, and we can use them concurrently. The way we use the Drift database in a subscription. Again, the same reg sub function we've seen, but in addition, we pass the ID of the database implementation that we've registered. In this case, the handler function is a query. This is the format of a query for a Drift query. And the result of this will return a stream, which Redash will in turn deliver using the normal subscribe mechanism that we've seen before. Also supported is the signal graph. So we can, again, subscribe. We can have Drift subscriptions subscribing to other Drift subscriptions, and have our computation function do whatever we need with the preceding results. When it comes to events, we can use the same reg event fx or reg event db functions, but we return, instead of the db effect, we return the drift effect or rxdb effect, etc. And here we define the function of how our mutation query should look like. So this is a typical update mutation in a Drift database. Importantly, we do not actually do the mutation here. As in the reframe spirit, our event will not be side effecting. It merely returns a function describing what the mutation should be. And Redash will in turn execute this mutation when it executes the other side effects. And the same counts for RxDB. So I think that is a pretty nice feature that will hopefully graduate to a release in Redash in the coming weeks or months. I think that's about it. Who's behind it? So my company, HDI, we've developed it. None of the features that I've shown today is unique to Redash. It is all based on the ideas popularized by Reframe. So all credit goes to them, except for maybe this last database demo that I've shown. Everything else is really Reframe ideas that we would like to use in ClojureDart. So we've implemented the features of Reframe in Redash that we want and use. So not all of the Reframe features are implemented. So if anything is missing that anyone would need, community contributions are welcomed. And we use Redash in our development for our applications at the moment. So you can say we eat our own dog food, and at least as long as we use ClojureDart, we are committed to maintain Redash as a result. Where do we go for help? We have documentation in Redash's repository. They're published to Clojure Docs. We have some samples that is also accessible from the README, many of which we can launch in the browser itself. And they cover some high-level generic use cases that will give you an indication of how to achieve a certain goal. And lastly, Clojurians Slack on the ClojureDart channel. You'll find me lurking in the shadows every now and then if there's anything you need. And I think that covers it. Thank you very much.